So, period 9, you're making a brief appearance in the video, but you're not signing any of the release forms, so don't do anything ridiculous. We have just proven this amazing fact about power functions. Let's do two more little things. Okay, here comes them now, to be followed by a boring theorem. What do we think the derivative is of like constant times a function? And why? Just gonna call someone. Callie, conjecture.
Multiply stuff.
Wait, can you be more specific?
No,
if I have some function and I have some kind of constant times that function, what can I say about the derivative of the new function?
Whatever Gabe's gonna say.
Oh, come on, don't do that. Just say anything. What happens when I multiply a function by a number?
It gets bigger faster.
It gets bigger, yeah, like more specifically. Okay, yeah, I guess that's pretty good. Okay, Gabe, I guess I'm calling on you. Gabe.
I mean, it's like that constant times the derivative of the function.
Yeah, think about some function like, sine or something like that, right? When you multiply it by some number, it just stretches it out by that amount. So if it stretches it out by that amount, what do we think is going to happen to the slopes of all the tangent lines? Stretched out by that amount, right? Yeah. Okay, so I think that this might be that the derivative of b times a function is just going to be b times the derivative. Let's see if that's indeed true. What I'll do is I'll define a new function g, and let this new function g be just b times f of x. And so what I want is the derivative of g. Does everyone see what's going on here? Do it out using the definition of the derivative. Just takes about 5 seconds. Does it make sense? Yeah. You just don't feel like doing it? So we said the limit is h goes to 0 of g of x plus h minus g of x all over h. And what is all that stuff? What is g of x plus h? Yeah, by definition, g of x plus h is just b times f of x plus h. And what is g of x by the definition of g? It's just b times f of x all over h. What can I do now?
Take it out.
Yeah, just take out the b, right? Yeah, we just take out the b. So if we take out the b, we get b times the limit as h goes to 0 of f of x plus h minus f of x all over h. Michael Clark's a little bit boring, but it's kind of like I kind of just want to do this once and then I just know that this is true. What is that thing? Do you recognize that limit? Yeah. Wait, it's what?
F prime of x.
It is just f prime of x. Okay, so indeed we have just proved a rule that says that the derivative of a constant times a function is just a constant times the derivative. All right, this enables me now to use the power rule to be able to take the derivative of, for example, I don't know, 5x to the 4th. What is the derivative of 5x to the 4th, or Gita? 20x cubed. Using this rule we just learned, she says it is 5 times whatever the derivative of x to the 4th is, and the derivative of x to the 4th is 4x cubed, so it's just 20x cubed. Cool, cool? Say cool. Okay, good. Another thing that's like a little bit boring, but is definitely important. What is the derivative of the function which is f of x plus g of x? Someone have a conjecture. This is actually not obvious. Or at least it's not totally obvious. Raphael.
Just f prime of x plus g prime of x.
Why?
It's like just the rate at which like f of x increases plus the rate at which g of x increases, so you just add them together.
Yeah, I guess that's true, right? It's kind of like, right? If like, I don't know, if f is the speed that a car is driving and g is the speed that the entire city is moving, right? Then, so if the entire, no, okay, wait, what's a more reasonable example? Yeah, sure. So if an entire city is being dragged at a rate,
What about a boat?
The Earth is
What about a
rotating.
What?
Boats.
What about a
Boats?
A person on
It
a
should be on a boat.
That's one of the states from Mortal Engines.
Person on a treadmill on a boat.
You can-
Okay, yeah, that's good. Okay, I like that. I like that. So let G be the position of a boat in the ocean. The boat's moving, like, cruise or something. F is the position. No, this doesn't really work. All right, let's move on. Let's just do the math. Doing the math. Anyway, it kind of makes sense that the rates just add, right? The total rate of growth of this thing is just the sum of the rates of growth of both of these. So what I'll do is I'll define a new function. Let's call it, need a new letter.
K.
Q.
J.
K. Let's define a new function K to be, let K of x be f of x plus g of x. Okay, so by asking for the derivative of the f plus g function, I'm really asking for the derivative of the k function, right?
Prime of X?
What?
K prime of X?
Yeah, I guess I'm really just asking for k prime of x, right?
Exactly.
Yeah, it's the same thing. So what is k prime of x? Well, it is by definition the limit as h goes to 0 of k of x plus h minus k of x all over h. What do I do now? Caleb Robel's mumbling some stuff that I think is correct, which he says is, well, now use the definition of k. K of x plus h is, by the definition of k, just f of x plus h plus g of x plus h. That's k of x plus h, right? And then minus k of x, which is f of x plus g of x. Everybody with me? This is like not that hard, right? It's kind of theoretical, but pretty easy. Okay, now what? Just reorganize and split. Exactly. Reorganize and split. Use a limit law, which says that the limit of a sum is the sum of the limit. And so I can rewrite this as the limit, h goes to 0, of f of x plus h minus f of x all over h. This mark is kind of dying. Plus the limit as h goes to 0 of g of x plus h minus g of x all over h. And this is by definition f prime of x, and this is by definition g prime of x. Okay. I now know basically 4 things, all on this board. No, some are on the other board. I know how to take the derivative of constant functions, 0. I know how to take the derivative of any power function. I know how to take the derivative of number times a function, and I know how to take the derivative of the sum of 2 functions. What now can I take the derivative of using all those rules and combinations recursively, blah, 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 shout it all out all at once?
Polynomial.
Yeah, that is polynomials. Exactly. I can now take the derivative. I can now take the derivative of any polynomial. So, for example, if I give you a function f of x equals 4x cubed minus 3x squared plus 5x minus 1, everybody use combinations of all of these rules to just determine what the derivative of that function is. And look up when you're done. Oh, it's taking longer than I expected. What are they doing over there? Table of boys, what are you doing? Are you done?
Yeah.
Okay. What's Adrian doing? Writing a letter to someone or something? All right, yeah, 4, so the derivative of 4x cubed is just 4 times the derivative of x cubed, and the derivative of x cubed is 3x squared. So this becomes just 12x squared, right? And the derivative of negative 3x squared is just the derivative of, I mean, is this easy? I feel like this is kind of easy, right? It's just negative 3 times the derivative of 2x squared, which is just 2x, so that becomes negative 6x. And the derivative of 5x is just, the derivative is just 5 times the derivative of x, which would be just 1. So this is plus 5, and then that's just 0, disappears. Whoa! It is now really, really, really easy to take the derivative of polynomials, which is good because it's a pretty long process taking the derivative every single time. It's kind of annoying. All right, before we move on to other more exciting things, very occasionally I think there are alternate derivations which are just so important and so different that I can't possibly skip them. And so what we're going to do right now is I'm going to give you another example of this is every teenager's favorite thing to do in the oral is just do things over again that we already did. So I'm going to rederive the formula for the derivative of x but in a different way. And basically what I'm going to do is the other way of doing a derivative. In other words, what am I talking about, Eleanor?
The limit as x goes to c or
Yeah.
a.
Let's just yeah.
Okay.
But cube.
No, we got a.
Of f of a or f of x minus f of a over x minus a.
Yeah. Yeah, in other words, I'm going to define some function f, which is x to the n. And now I'm going to take the limit as x goes to a of fx minus f of a over x minus a. And if I get something out of this, then I'll have some formula in terms of a. So let's actually do this right. So what is this? More particularly, this is the limit as x goes to a of what do we have here? Everyone do this. This is like x to the n minus a to the n over x minus a. Right? Okay. What is that limit?
Wait,
You know?
I have an idea.
Notice how this is kind of different from what we did before, right? The binomial theorem is now suddenly totally irrelevant or absent or something. I don't know. Vegeta, what can we do? Did you raise your hand? Yeah, what is it? What is it?
You can bring the n down, do n times x to the n minus 1.
No. You're trying to. That's the rule. That rule about how to take derivatives is what we're proving right now. I mean, some crap like this has come up before, right? Remember we did stuff like we very recently, like maybe last night's homework practically. You know, I asked you to take the derivative of x cubed or something, right? And how did we do that? We said that this was the limit as x goes to a of x cubed minus a cubed over x minus a, right? We've done problems like this, and then what do?
You factor out the x minus a.
You factor out the x minus a and you cancel and hopefully it all works out. What are you nodding? Are you saying we should do that here?
But
Well, I
we
mean,
don't-
you'll end up having a factor that's x minus a because it's a difference. So no matter, even if it's like difference of squares, it'll still work.
Yeah, how do you
Like,
I mean, so
different-
like,
What?
Yeah, it's like yeah. So
Make it
Sam was like, yo, we have a difference of squares formula. We have a difference of cubes formula. We have a difference of fourths formula-ish because it's kind of like no, or maybe we don't. I don't know what we have. What we need is a difference of nths formula. Gabe, you have a difference of nths formula?
No, but I feel like you can. There's probably some stuff you can cross out. Maybe not.
Right.
Like
Yeah, I feel like we can just do this, right? I feel like we can just do this. So let's move over here for a minute. Let's see if I'm still in frame. I'm not sure if I am. But yeah, can we just derive a difference of nths formula? Am I still in frame? Can you check?
Which bed are you writing on?
Get it right over here.
No.
Okay, can you move the camera? So what we need to do now is like a little bit of algebra 2. We need to derive a formula for the difference of nths. We could very well have done this back in pre-calc C or even earlier. So we have some function. This function is x to the n minus a to the n. Someone say something smart about this function. That's relevant to us. It is a polynomial.
it can be polynomial.
If you like.
Why?
Huh?
No, keep talking.
If you like want it to be x minus a times something,
Yeah.
then all of the terms need to cancel except for the first and the last. So you just need to like.
Okay, it's even simpler though. We did a whole unit on polynomials about this. You guys seem suddenly bereft of. Yes.
It has one root.
Yeah, it has a root. Can you think of a root, Kid Rebel? A is a root, yeah. If you plug in A, what do you get?
0.
0. So since A is a root, aha, all that crap. Yeah, exactly. Since A is a root, x minus A is a factor. That's called the factor theorem. That's the thing about polynomials. So indeed, with the combination of help from the class, since A is a root, then I just know x minus A is a factor. And so okay, that means this is definitely going to work, right? This function is definitely in the form x minus A times crap. Okay, now that I've proven that it is definitely in that form, I just have to figure out what that actual formula is. How can I do that? 2 options. Polynomial long division or synthetic division. Let's do synthetic division because that's shorter. So we have to be kind of careful now, right? How do I do, like, what are the coefficients of x to the n minus a to the n? 1.
Dot, dot, dot.
And then just like a lot of zeros, right? All the zeros. And then eventually, dot, 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 we're going to end up with negative a to the n is like my constant term. Are you guys following this? 1 is the coefficient of my x to the n term. This is my constant term. Okay, and I do a little bit of this. And now way over here, I'm going to be plugging in a. So this is just shorthand for dividing through by x minus a. Okay, let's do it. What do I do? Bring down the 1, multiply by a. Then I get an a. And then I get, yeah, well, not sort of. Bring down the a and then a squared. Add, I get a squared. Multiply, I get a cubed. Is everyone following this? And then add, I get a cube. Okay, I'm getting tired of doing this, so I'm just going to throw in some dot, dot, dots pretty soon. Can we skip to like the second to last one? What must this be just before, what must the last thing be? It must be a to the n minus 1, right? That has to be a to the n minus 1 because then I do that last multiplication by a and I get back up here with a to the n. Is everyone following all this? And then when I do that, I get a 0. Okay. Congratulations, class. You have just derived the formula for the difference of n's powers. It looks like this. And now we're going to do it. This is the limit is x. So now you're going to move the thing back, I think, or maybe something. I don't know. I'm going to factor x to the n minus a to the n as x minus a times. Someone tell me what to write. X to the what? X to the n minus 1. And then what's the next term? Ax to the n minus 2. Next term? A squared x to the n minus 3, etc. Okay, let's skip to the second to last term. Or maybe we just skip to the last term. What's the last term? Yeah. It's a constant, but the last one is just boom. Ta-da! Is everyone satisfied with this? And then this is all over x minus a. Okay, of course. And now what can I do? Cancel. So that's kind of cool. And so now it's no longer an indeterminate limit. So this is the limit as x goes to a of x to the n minus 1 plus a times x to the n minus 2 plus a squared x to the n minus 3 plus dot 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 all the way over to the constant term. Okay, but what is this limit?
X or 8.
Just plug a in and see what happens. If I plug a in here, what do I get? What? Wait, are you guys following this? Okay, just pretend you are. If I plug a in, what do I get? A to the n minus 1 plus, what do I get now?
It's just a to the n minus 1.
It's also a to the n minus 1, right? Because this is a to the n minus 2, but times another a. Okay, what about over here? It's also, yeah, now it's a to the n minus 3 plus another a plus another a, so that's also a to the n minus 1. So all of these guys are going to be a to the n minus 1 because as this exponent goes down, this one goes up. And the final term is also a to the n minus 1. How many of these do I have?
N.
Yeah, I have n of these because, like, right, it's an n minus 1 degree polynomial plus the constant term, so I have n of these. And thus, this limit is n a to the n minus 1. Exact same formula, right? The formula says that the derivative, that f prime, if f of x equals x to the n, then f prime of a is n a to the n minus 1. This is an alternate derivation of the power rule. I like this because it's sort of, first of all, it shows that the binomial theorem per se is not like needed here exactly. This is more like a theorem of algebra. I think what makes this kind of derivation a little bit cooler is it shows why the derivative of a polynomial has to itself be a polynomial, I guess, right? Because you're sort of doing this long division thing. All right, that was it. Let's turn the camera off. Bye.